Expected mean is square in random effect model when all factors are random. Check my other 3 videos on three different situations that we have created, especially the first video on expected mean is square. So to find expected mean is square, the first thing we need to do is to write all the effects and their variances. So that's the effects on the first column, and then variances, and then the subscripts of that effects. For example, AB effect subscript IJ, and their variance is sigma square AB. And then also create another few columns for the factor A, factor B, factor C, and the replications, and write their subscript right here. Now the first rule is if the column subscript does not match, or the the row subscript does not contain the column subscript, then type the labels or the replication. So in this case, this I does not match with J, so on this cell we write A. Similarly on this one, for example, this row subscript JK does not contain this L, therefore we type in here. Similarly, all this can be checked. Now the next one is for the dead subscript. If the subscript is dead or nested, and then if the the row contains the column subscript and it's dead, then you type 1. So for example, IJK contains I, so type 1. Contain J, type 1 here, and then contain K, type 1 there. And then next one is for random fixed. If we say if the row subscript contains the column but it's a random factor, then it's 1, and if it's a fixed factor, then it's 0. So in this case it's all random, so all of these empty cells are 1. And then next thing is whatever expected mean square we are interested in, we have to mask that. So in this case, for example, we are interested in finding C, expected mean square for C. So we mask or delete that C, we don't see that, and then we multiply all of this. So multiply this variance and then this 3. So sigma square A times 1 times B times N, so that is A B N sigma square A. For example, for this one, we multiply 3 ones times with this sigma square, so that becomes sigma square only. Now, to find C, which is the rule number 5, what you have to do is add all the variance components that contain C. For example, this one does not contain C, so that doesn't come in C variances. This one does not contain B, so it's not included. This one does not contain C. So to calculate C, it's going to be basically the sigma square plus N sigma square ABC plus AN sigma square BC plus BN sigma square SC plus this ABN sigma square C. So that was actually rule number 5, which you will see in the next slide, this one. So this is the expected mean square for C. Now for all of these next, so we can find like this. And remember, for the F statistics for ABC, there is no exact F statistics, so we have to kind of devise a formula to do that. So if we, for example, we are interested in C, then if we do these linear combinations, then you will see that it's only C is left. So MSSC plus BC. So if we add AC plus BC, that's 2, AC plus BC, this 2. If we add these 2 minus this ABC, then we'll have this one, and this one cancel. So we'll have sigma square plus n sigma square ABC plus bn sigma square AC plus n sigma square ABC. Well, one of the ABC is cancelled, so this will actually will have this C. So the denominator for F statistics would be this one. So we have to find a linear combination of that, because the exact F statistic does not exist. For example, for the BC, we can see the exact F statistic, because the AB or BC or AC, and the AB is associated with the ABC error. So this AB part is basically, this is the ABC, so sigma square plus n sigma square ABC. So this AB is associated with ABC, so we can simply use the ABC error as a divisor for F statistics to calculate the F statistics for ABC. I hope that explained the random effect model, expected mean square.